This open-source repo supercharges AI agent memory. CocoIndex keeps the data behind AI agents and LLM apps continuously up to date. When a document, repo, or database changes, it tracks what changed and updates only the affected outputs. That means a RAG index, code index, or graph memory can stay fresh without rebuilding everything from scratch. For agents, this is the difference between a memory dump and a memory system. The repo starts from a practical data problem. Agents depend on source material that changes while they are running. A local repo gets new commits, a policy page gets edited, a customer record changes. CocoIndex gives those changes a way to flow into the index or memory store. Stale embeddings make an agent reason from old information. A cleaner source of truth matters more than another prompt tweak. One clear use case is code context. CocoIndex code is presented as an MCP server for coding agents. It keeps repo context updated as the code changes. That helps because coding agents often fail when they see one file but miss the rest of the system. A live code index gives agents a broader repo view without sending the whole code base every turn. That matters in large repos, where the context window is never big enough to carry the whole project. The programming model is direct. CocoIndex describes itself as React for data engineering. You declare what the target should contain, and the engine keeps that target synchronized with the latest source data and transformation code. Instead of writing a one-off pipeline loop, you write the transformation and let the engine handle updates. The delta model is the core behavior. If a source file changes, CocoIndex updates the affected outputs. If transformation code changes, it can invalidate the records that depend on that code. That is what a live AI data layer needs to know: what is stale, what is still valid, and what has to be rebuilt. The index becomes a maintained artifact instead of a file you periodically overwrite. GitHub shows 7.9 thousand stars, 585 forks, 1,732 commits, and an Apache 2.0 license. The repo is also more than a README around a demo. It has a Python package, a Rust core, docs, examples, coding agent skills, release automation, and an active issue tracker. That is the shape of an infrastructure project, not a weekend script. The repository explains the system clearly. The README opens with the core promise, then shows the code agent use case, the quick start, the React-style model, the incremental engine, and concrete examples. The repo tree backs that up with docs, implementation code, agent skills, and CI workflows. It gives people enough context to understand the idea and enough starter paths to try it. That matters because infrastructure repos are easier to trust when the examples match the architecture. The engine sits between changing sources and downstream targets. The sources can be files, apps, data systems, or event streams. The targets can be vector, graph, or relational stores. The shared control plane in the middle does the hard work. CocoIndex records versions, lineage, cached outputs, scheduling, metrics, and failures around the transformations. That makes the flow easier to operate because the update logic is not scattered across custom scripts. Incremental work matters because AI pipelines often spend too much cost on repeated work. If one handbook page changes, you should not have to process the entire handbook again. CocoIndex makes that behavior operational. It keeps the target fresh, keeps lineage back to the source, and skips the work whose inputs and code have not changed. For production agents, that can be the difference between an index that is refreshed often and one that quietly falls behind. Lineage matters when an answer is wrong. A bad answer from an agent is not always a model problem. It may come from stale source data, a broken parser, a bad chunk boundary, or a target row that no longer matches the source. CocoIndex keeps source-to-target relationships visible so the pipeline can be debugged as a data system. It also gives teams a better way to audit why a piece of context entered the system. The CodeIndex example shows why this is useful for developer tools. You walk a repo, chunk source files with syntax awareness, embed the chunks, and write the result to a vector store. A normal script can do that once. The harder part is making it stay correct after every commit. CocoIndex is designed for that second part, where only touched files and dependent outputs need to refresh. In a fast-moving repo, that is the difference between search that reflects main and search that reflects last week's backfill. The PDF example is the classic RAG workload. Pull documents from local storage, S3 or Google Drive, extract text, split it, embed it, and write the chunks to a vector database. cocoindex does not make that idea exotic, it makes the operational behavior clearer. When the source changes, the index is supposed to follow without someone remembering to run a full batch job. The same pattern applies to the documents teams actually change every week. The knowledge graph example moves beyond search. Conversations, meetings, support calls, or transcripts can be transformed into people, topics, decisions, and action items. Then the result can land in graph stores like Neo4j or Kazoo. That is a better fit for some agent memory problems because relationships matter. The agent needs to know who said what changed, and how facts connect. For long-running agents, that relational memory can be more useful than a bag of similar chunks. cocoindex is not only a chunking recipe, and it is not tied to one vector database. The repo is closer to an incremental data framework for AI workloads. The same style of flow can support vector search, structured extraction, graph memory, message publishing, or file transformation. The framework is about keeping derived state correct. That is why it fits agent memory. The system manages updates, not just queries. Setup is intentionally small. The README starts with pip install, then shows a Python flow for documents, embeddings, and a Postgres target. You write the transformation in Python, but cocoindex owns the update behavior. Run once for a backfill, then run again when the source changes. The scale story is straightforward. Large corpora cannot be reprocessed like toy DMOS forever. Once a company has many repos, many documents, or a steady stream of internal notes, full recompute starts to break down. cocoindex is built around the opposite assumption. Process once, remember what each output depends on, and reconcile changes as they arrive. The bigger the corpus, the more the update strategy becomes the operational risk. The latest GitHub release is version 1.0.2, published on April 29, 2026. The repo has active CI, docs checks, link checks, and release automation. That does not guarantee maturity, but it does show maintenance around the parts that infrastructure projects need. For a framework that sits between source data and production agents, that maintenance signal matters. Compared with a simple script, the advantage is state. A script can read a folder and push embeddings. cocoindex keeps enough state to know what changed and what is still valid. Compared with a generic orchestration tool, the advantage is the AI data model. The repo talks directly about embeddings, retrieval, graph memory, source lineage, and agent context. That makes the abstraction closer to the problem. It can also be easier to reason about than stitching together one script per data source. The trade-off is that this is infrastructure, not a magic agent button. You still need to choose the data model, the source boundaries, the target store, and the embedding strategy. Incremental systems also make correctness more important because bad invalidation logic can leave stale state behind. cocoindex is best understood as a cleaner foundation for agent data, not a finished answer to every retrieval problem. Teams still need tests around transforms and a plan for reprocessing when assumptions change. Bottom line, cocoindex is worth watching for teams building agents that need memory to stay current. The repo makes a specific bet. Agent context should be live, explainable, and cheap to update. That is a practical infrastructure problem, not just another chatbot demo. The repo is early enough to evaluate carefully, but concrete enough to clone and study now. For more GitHub repo deep dive videos, subscribe to Build Things with AI.